Welcome everyone. The question that is displayed on the screen, it is a CBSE previous year question and it comes in the year 2023 and this is the third question of the paper. A current of 0.8 ampere flows in a conductor of 40 ohm for 1 minute. The heat produced in conductor will be option A 1445 joule, option B 1536 joule, option C 1569 joule, and option D 1640 joule. So according to this we can say here is an conducting resistor and capital R is the resistance, I is the current and T is the time for which the flow occurs. Then we know that the heat generated in it is H equal to I square into R into T. But why so? If I want to figure it out, then let us move to another place, another page, that what is resistance that we need to understood. Okay, we know if I say this is a conducting bar and it comprises of the free electrons like this way, okay, which are basically taking part in conduction and basically carrying the electric energy from the higher potential to the lower potential point. And positive charges are here, just like here positive charges, immobile positive charges from where the free electrons are coming out and basically taking part in conduction. So all these are positive charges. Lots of positive charges are there. Obviously if I take it is an 63 gram copper, then obviously there is 6.023 into 10 to the power 23 copper atoms, and if 90% of the copper atom basically leaves one of its electron from the valence shell, then all of these are the immobile positively charged ions. And when the electrons basically try to move through it, if the potential difference is applied across the both ends, then its path will be zigzag. What is the reason behind this? If the electron starts its journey from here, okay, then it strikes with the immobile positive ion, say, okay, and due to this collision it basically dissipated the amount of energy as a heat energy. Okay, so it is not only collide with the positively charged ion, it's collide with the other free electrons, it collide with the surface of the conductor. So there is the several types of collisions are there, which basically we can say by one word, and that is our resistance. Okay, now heat generated, it is said the heat generated is proportional to I square. What is I? I is equal to Q divided by T. What is Q? According to the principle of quantization, Q is equal to NE divided by T. That is, if the electrons are flowing through a conducting bar, then the current constitutes, and if you increase the current flow, then the heat generated is proportional to the square of the current flow. If you send more current, that means the free electrons along the length of the conducting bar, more electrons are passing through the cross-sectional area, more collisions will be there. As much collisions are there, more heat will be generated, and obviously H is proportional to the capital R, or we can say the distributions of the immobile positively charged ions and free electrons on the surface of the conductor. So as much collision it suffers, it generates the heat energy. Next is H is proportional to T. As long the electrons have traveled, if the length of the conductor is long, or if through a loop it just flows for a long time, then the electrons will suffer more and more collisions, and the energy lost due to collision again comes out as energy. So we can say this is the essence of the Joule's law. Now qualitatively we have understood that why H is dependent on I, why h is dependent on r and why h is dependent on the time of the flow. So here the current flow is my 0.8 ampere. Okay, the resistance of the conductor is the 40 ohm. The time of flow is 1 minute. Okay, that means 60 seconds. Okay, because minute is not the SI unit. Okay, so you have to convert it into the SI unit because ampere, ohm, all are in SI unit. So let us put this in the equation, fundamental equation, H is equal to I square RT. So H, I is 0.8 whole square. What is R? R is 40. And what is T? T is simply 60. Now 0.8, so we can say 8 by 10 multiplied by 8 by 10 multiplied by 40 multiplied by 60. So 0, 0, these are cancels out. So here is 64 and here is 24, 4 into 6. So if I do this multiplication, and obviously the sense tells us that B will be the answer because 4 into 4 is 16 and there is no other alternatives. But we have to check it. 64 multiplied by 24. Okay, so 4 4 is just 16, 1 in my hand, 6 4 is 24, so 256. 64 into 2, it is 128 divided by 6, 8 5 13, 1 3 13, 2 to 4 plus 1 5. So I think you have also calculated, and 1536 joule is the answer. Option B is the answer. Thank you all of you.